Hello everyone! In this video, we're going to finish the discussion on moments and center of mass. Okay, dito sa final video na to, ang context naman natin is yung tinatawag nating centroid of a plane region or the center of mass of a lamina. If you're wondering what a lamina is, pwede nyo lang isipin na meron isang bond paper or kahit anong papel. So, it's a thin sheet of paper. Tapos, hahanapin natin yung balancing point nun. So, meron kang plane, hahanapin mo yung balancing point. And for the purposes of our course or our subject, ang i-discuss lang natin is yung uniform yung density niya all throughout. Okay? So, suppose we have a region R bounded by f of x, the x-axis, x equals a, and x equals b, and the density of the lamina is denoted as rho. So, you can see an illustration sa right. Ganyan yung hahanapan natin ng centroid or yung center of mass. Now, since itong plane na to has a uniform density, pwede nating maisip na somewhere sa gitna, nandito yung ating centroid or yung center of mass. The center of mass, since nasa two-dimensional space ulit tayo, pwede natin i-represent ulit as x bar, y bar. Okay? Again, kaya siya somewhere na nasa gitna kasi sabi naman na or we have made a remark that we're going to consider a uniform density all throughout the plane. So sure tayo na if we want to find the balancing point, it should be located somewhere in the center or it should be located in the center of the plane. Having said that, if we want to get the mass of this plane, gagamitin natin yung concept ng density. Now, in the previous video, we were introduced to the concept of what we call the linear density, kung saan kinoconsider natin yung ratio ng mass at saka ng length. Dito naman sa plane region, ang ating density will now be taken as mass per unit area. Okay? So if we manipulate this relationship or this equation, we can actually get that the mass is equal to the density times the area. Or sa context natin ng plane region na to, yung ating mass is equal to the density, which is rho, times the area of this region. Pero yung area ng region na to, na-discuss na natin nung first quarter kung paano kuhanin ang area ng plane region using the concept of integrals. So the area of R is actually the definite integral from a to b ng f of x dx. Okay? Next, since nasa two-dimensional space tayo, yung center of mass is again represented by a point x bar, y bar, na technically same lang yung una nating ma-introduce ang center of mass sa two-dimensional space. So dito, ang x bar, y bar natin will again be equal to m sub y over m sub x over m. So, kailangan ulit natin ng moment about the x-axis at moment about the y-axis. But in the general sense, the moment is still mass times distance. Okay? Mass times distance from the axis of rotation. So, mass times distance from either the x-axis or the y-axis. So, ibig sabihin, if we want to get the moment about the x-axis, this is technically the mass times the distance from the x-axis. Okay, so balik tayo sa diagram natin. Yung mass, given na tayo nito, yung distance from the x-axis would be this one. Now, since sure tayo na nasa gitna yan because we have a uniform density, yung distance from the x-axis would now be f of x over 2. This entire thing is f of x, pero since nasa gitna, f of x over 2. So yung moment about the x-axis would now be represented as rho times the definite integral from a to b f of x. This gives us the mass, or this is the mass. Tapos yung distance from the x-axis is f of x over 2. Okay? And in the similar manner, yung ating moment about the y-axis would be the mass times the distance from the y-axis. Now, yung distance from the y-axis, hindi naman natin kailangan i-divide by 2, no? So, kailangan lang natin ma-determine yung distance from the y-axis, which is technically this part here, which is just x. So, f of x times x dx. Our centroid, this is the center of mass, is x bar, y bar, which is again, moment about the y-axis all over the mass, moment about the x-axis over the mass. Now, if we want to simplify, technically, this is, in terms of the integrals, rho integral from a to b. Moment about the y-axis is this one. I-rewrite ko lang siya as x, f of x dx all over the mass. Rho, definite integral from a to b ng f of x dx. And then, yung moment about the x-axis is rho, definite integral ng from a to b. Then, simplify lang natin to, no? F of x squared divided by 2 dx all over rho times the definite integral from a to b ng f of x dx. Okay, mukha siyang nakakatakot kung isusulat natin this way. But take note, yung density dito is non-zero. So, technically, pwede nating i-cancel yung density. And then, note na yung denominator, this would simply be the area of the region. So, pwede nating isipin instead that the centroid is equal to 1 over area times the definite integral from a to b ng x f of x dx, or, and we have 1 over area ng definite integral from a to b of f of x squared over 2 dx. Now, para mas malinis, yung over 2, ilabas na natin. So, we have here 1 over twice the area times the definite integral from a to b ng f of x squared dx. Okay, so we're going to make use of this formula in order to get the center of mass of a plane region or the centroid of a plane region. Okay, so consider this example here. We want to find the center of mass of y equals square root of 4 minus x squared. So, okay, so the graph is given here. So, makikita nyo sa right, it's actually just a semicircle of radius 2. So, if we are going to get the center of mass of this plane region, so x bar, y bar, again, pwede natin gamitin is yung simplified formula natin na 1 over a, definite integral from a to b ng x f of x dx, and 1 over 2a, definite integral from a to b ng f of x squared dx. Okay, where a here is the area of this region. Okay, for the area, we technically just need to get the area of this semicircle. So, you can either use trig sub or pwede nyo isipin na kalahating circle lang to of radius 2. So, we can just get or just make use of the formula for the area of a semicircle to get that the area of this region is actually 2 pi. Okay? And then, pwede na natin gamitin itong formulas na ito. Okay, so for the x-coordinate of our center, we can think of this as 1 over the area. Yung limits of integration or yung bounds of integration natin would be from here to here. So, from negative 2 to 2 ng x square root of 4 minus x squared dx. We can use integration by substitution here. U equal to 4 minus x squared. Tapos, manipulate na lang yung given to get that this is 1 over 2 pi times 1/3 of 4 minus x squared raised to 3 halves to be evaluated from negative 2 to 2. Okay? At x equals 2, note that this will be 0 as well as at x equals negative 2. So this part here will just be 0. Next, we can get the y-coordinate of our center. So that is 1 over twice the area. So 1 over 4 pi times the definite integral from negative 2 to 2 ng square root of 4 minus x squared dx. This one is much simpler kasi magka-cancel yung square roots at yung square. So 1 over 4 pi, definite integral from negative 2 to 2 ng 4 minus x squared dx. From here, we can just apply the power rule. So 1 over 4 pi for x minus 1/3 x cubed evaluated from negative 2 to 2. Performing this correctly, we have 1/4, 1 over 4 pi, 1 over 4 pi times 32 over 3. Okay, so simplifying, we have 8 over 3 pi. To make this more clear, this is equal to 0. So our center of mass for this semicircle is actually located at the point 0, 8 over 3 pi. Okay, so 0, 8 over 3 pi will be located somewhere here. Okay, so it's less than 1. As you can see, medyo nasa gitna talaga siya ng ating semicircle. Okay, siguro somewhere here yan. Of course, it goes without saying na pwedeng more than one function yung kinoconsider natin, no? Parang nung kumukuha tayo ng area of a region, if it's bounded by several functions, mas complicated lang yung process natin. But it would still remain the same. No? Or yung concept behind it still remains the same. Okay, so if we have two functions f and g, wherein f is greater than or equal to g on the interval AB, and consider the lamina of uniform density bounded by the graphs of f, g on the interval AB. So yung uniform density natin dito, I forgot to include that the uniform density is rho. So the mass is still the same, density times the area. Iniba lang natin yung area natin. Okay? Yung area would now depend on the two functions. And yung moment about the y-axis, same pa rin. Yung area lang yung napalitan, as well as dun sa moment about the x-axis. Okay, so for the moment about the x-axis, notice na yung ating distance from the x-axis, ito na yun, yung distance from the x-axis is f of x plus g of x over 2. So, ibig sabihin kasi, if we have an arbitrary sketch of the graph here, let's say ito yung f of x, and then ito yung g of x. So, para malaman natin yung nasa gitna nitong dalawang functions, what we do is we take the average. So, f of x plus g of x divided by 2. So, ito yung distance from the x-axis. Okay? So, again, ito yung nasa gitna kasi we have a lamina of uniform density. Now, when simplified, magiging difference of two squares yan. And of course, the center of mass or the centroid would still be the same, x bar, y bar, pero yung area natin ay napapalitan. Okay? So for example, we want to find the center of mass of the lamina with uniform density rho, bounded by the graphs of f of x equals 1 minus x squared and g of x equals x minus 1. So, hanapin muna ulit natin yung area. So, the area is given by the definite integral from negative 2 to 1 ng 1 minus x squared minus x minus 1. Okay, solving this will give us definite integral from negative 2 to 1 ng 2 minus x squared minus x dx, which will give us 9 halves. Okay, so if we want to find x bar, or the x-coordinate of the centroid, this is equal to 1 over the area. Oops. Na-reciprocal ko na. 1 over the area times the definite integral from negative 2 to 1 ng x f of x minus g of x dx. Okay? Yung 1 over area, gawin na nating 2 over 9 times the definite integral from negative 2 to 1. Note na ito yung sinolve natin previously. So, ito yan. So, we can simply multiply it by x. So, 2x minus x cubed minus x squared dx. Simplifying, we have 2 over 9. Tapos, ito ay maging x squared minus x to the 4th over 4 minus x cubed over 3 evaluated from -2 to 1. Okay? If we evaluate this from -2 to 1, ang makukuha natin would be 2 over 9 times 1 minus 1/4 minus 1/3 minus 4 minus 16 over 4 minus 8 over 3 minus -8 over 3. So, plus 8 over 3. I simplify. We have 2 over 9 times 1 minus 1/4, 3/4 minus 1/3. That gives us that would give us 5 over 12. And then, magka-cancel to. So, we have minus 8/3. When simplified, this is 2 over 9 times 5 minus 32. So, negative 27 over 12, which will give us negative 3, 6, negative 3 over 6, or negative 1/2. Okay? Now, for the y coordinate of our center, this is equal to 1 over twice the area. So, 1 over 9 times the definite integral from -2 to 1 ng f of x squared. So, that is 1 minus x squared squared minus g of x squared. Okay, expanding and simplifying 1 over 9, definite integral from -2 to 1. Okay, this gives us 1 minus 2x squared plus x to the 4th minus x squared minus 2x plus 1. So, when simplified, ito ay magiging x to the 4th minus 3x squared plus 2x plus 1 minus 1. Okay. Dx. Okay, continuing the process. So, 1 over 9 x to the 5th over 5 minus x cubed plus x squared. Again, evaluated from -2 to 1. So, 1 over 9, 1/5 minus 1 plus 1 minus -32 over 5 minus -8. So, plus 8 plus 4. Simplify. Tatanggal to. We have 1 over 9 times 1/5 minus, we have -32 over 5 plus 12, or -32 plus 60 over 5. So, 28 over 5. So, we have 1 over 9 times -27 over 5. So, we have -3/5. Therefore, The center of mass is at the point x bar, y bar with coordinates negative 1 half, negative 3 fifths. Okay, now similar dun sa discussion natin sa area of a region, pwede tayong gumamit ng either vertical rectangles or horizontal rectangles. Na kapag horizontal rectangles yung ginagamit natin, ito yung magiging formulas natin. Okay? So kung mapapansin nyo, these are functions in terms of y. Tapos, technically, parang pinagbaliktad mo lang yung x bar saka yung y bar.